Imagine everything you know squeezed into a tiny point. All the stars, planets, galaxies, and even the vast stretches of empty space compressed into a minuscule dot. This point is smaller than a grain of sand. In fact, it's so small that it defies our everyday understanding of size and scale, smaller even than an atom. It's almost impossible to fathom something so minute. This is the idea of a singularity, a point where the laws of physics as we know them break down. Scientists believe our entire universe was once like this, a single, infinitely dense point that contained everything. It's hard to imagine such a thing, the vastness of space, all condensed into something so incredibly small. How could everything we see around us come from something so small? It's a question that boggles the mind. This singularity wasn't just tiny, it was also incredibly hot and dense. Temperatures and pressures beyond anything we can experience. It contained all the matter and energy that would become stars, planets, and even you and me. Everything that exists today started from this singular point. This idea might seem strange. It's a concept that challenges our understanding of reality. But it's based on years of scientific observations and calculations. Decades of research and data collection have led us to this understanding. The singularity is where our understanding of the universe begins. It's the starting point of everything we know. It's the starting point of an incredible journey. A journey that has led to the formation of galaxies, stars, planets, and life itself. The time before the Big Bang is a mystery. We can't see beyond this point in our universe's history. It's like trying to look back before the first page of a book. The laws of physics, as we understand them, break down at the singularity. Time and space as we know them didn't exist. This makes it difficult, if not impossible, to describe what, if anything, existed before the singularity. Some theories speculate about other universes or dimensions, but these remain in the realm of speculation. What we do know is that from this singularity, something extraordinary happened. The universe as we know it began. The Big Bang. The name might sound like an explosion, but it's more accurate to think of it as a rapid expansion. Imagine a balloon being inflated incredibly fast. That's similar to what happened to the universe. About 13.8 billion years ago, the singularity began to expand. This expansion wasn't about something exploding into space. Instead, space itself was created and stretched outwards in all directions. This expansion continues today. As the universe expanded, it cooled. This cooling allowed matter to form from the initial energy. Tiny particles combined to create the first elements, like hydrogen and helium. These elements would eventually become the building blocks for stars and galaxies. The early universe was like a giant cosmic soup. It was filled with particles colliding and interacting. Over millions of years, gravity began to pull these particles together. These clumps of matter grew larger and denser. Eventually, the pressure and heat at their centers became so intense that nuclear fusion began. This is the process where atoms fuse together, releasing enormous amounts of energy. The first stars were born. These early stars were massive and short-lived. They burned bright and then exploded as supernovas. These explosions scattered heavier elements like carbon and oxygen into space. These elements would later become part of new stars, planets, and even life. There are some common misconceptions about the Big Bang. Many people have heard of it, but not everyone understands what it truly means. One common myth is that the Big Bang happened in a specific location in space, like a firework going off in the night sky. But the Big Bang wasn't like an explosion in a pre-existing space. Instead, it was the rapid expansion of space itself, occurring everywhere simultaneously. Imagine a balloon being inflated. Every point on the surface moves away from every other point. That's similar to how space itself expanded. Another misconception is that we can see the edge of the universe as if it were a giant bubble with a defined boundary. Because light takes time to travel, looking into the distance is like looking back in time. The farther we look, the older the light we see. We can see the light from distant galaxies as they were billions of years ago, giving us a glimpse into the universe's past. But we can't see the edge because there isn't one, or at least not in the way we typically think of it. The universe doesn't have a clear boundary like a planet or a star. Another myth is that we could hear the Big Bang if we were there. Sound needs a medium to travel through, like air or water. In the vacuum of space, there is no air to carry sound waves. The early universe was a very different environment, filled with hot, dense plasma. While this plasma could carry sound waves, it wasn't the kind of sound we could hear with our ears. As the universe expanded and cooled, it became the vast, mostly empty space we know today where sound cannot travel. Understanding these myths helps us appreciate the true nature of the Big Bang and the incredible journey of our universe. The universe is still expanding today. This expansion isn't slowing down. In fact, it seems to be accelerating. Scientists believe this acceleration is caused by a mysterious force called dark energy. We don't know much about dark energy, but it seems to be pushing everything in the universe apart. The more the universe expands, the more dark energy there seems to be. This continuous expansion has profound implications. It means that galaxies are moving farther apart. It also means that the universe is cooling down as it expands. The future of the universe is uncertain, but our understanding of the Big Bang helps us to explore these possibilities. The Big Bang theory is one of the most important discoveries in science. It marks the beginning of our universe, a moment of creation that set everything in motion. It explains how our universe came to be and how it evolved over billions of years, from a hot, dense state to the vast cosmos we observe today. It provides a framework for understanding the origin of everything we see around us, from the smallest particles to the largest galaxies. But the Big Bang is not the final answer. It is just the beginning of our quest to understand the universe. It raises as many questions as it answers. What happened before the Big Bang? What lies beyond the observable universe? What caused the Big Bang? What is dark energy, the mysterious force driving the accelerated expansion of the universe? Are there other universes out there, perhaps with different laws of physics and different forms of life? These questions continue to drive scientific inquiry, pushing the boundaries of our knowledge and imagination. We are constantly refining our understanding of the universe, using new telescopes, experiments, and theories. Each discovery brings us closer to unraveling the mysteries of the cosmos. The exploration of the cosmos is a journey of discovery that continues to inspire and amaze us. It reminds us of our place in the universe and the endless possibilities that lie ahead. The study of the universe is a humbling experience. It reminds us of how much we don't know, but it also fills us with a sense of wonder and awe. The universe is a vast and mysterious place, full of beauty and complexity. As we continue to explore the cosmos, we're likely to make even more incredible discoveries. The Big Bang theory has given us a glimpse into the beginning of the universe. But the story of the universe is far from over. The quest to understand our place in the cosmos is a never-ending adventure.